Energy of an electron in nth orbit. Suppose I am going to consider this is the nucleus of a charge Ze and electron revolving around the nucleus of charge E. Then there is an electrostatic force between these two, Ze and E. That electrostatic force provides the required centripetal force. So centripetal force formula mv square by r. Who provides this one? Electrostatic force between these two. What is the electrostatic force? 1 by 4 pi epsilon naught Q1 Q2. What is Q1? Electron charge. What is Q2? Nucleus charge by distance square. What is the distance between the electron and nucleus? That is the radius square. So from here, what is mv square? Mv square. Here r get cancelled and r square, r times. That is 1 by 4 pi epsilon naught z into e times e square by r. This is mv square. This is I am going to consider 1. And we know that angular momentum mvr is equal to nh by 2 pi. This is the angular momentum formula. mvr is equal to nh by 2 pi. Angular momentum formula. So n is the orbit number. In any orbit, what is the angular momentum? H by 2 pi. First orbit and 1h by 2 pi. Second orbit 2h by 2 pi. Third orbit 3h by 2 pi. Like that. So angular momentum formula mvr. mvr is equal to nh by 2 pi. Squaring on both sides. Then what happened? M square, V square, R square is equal to N square, H square upon 2 square is 4 pi square. This is considered 2. Now do one thing. Equation 2 divided by equation 1. Equation 2 divided by equation 1. What is the left hand side of the equation 2? M square, V square, R square by what is the right hand side of the equation 1? MV square, which is equal to right hand side. N square H square by 4 pi square, N square H square by 4 pi square upon what is the right hand side of the first equation? 1 by 4 pi epsilon naught Z square by R. 1 by 4 pi epsilon naught Z E square by R. Here M get cancelled, M square M times V square cancel, and what remains? M R square. 2 by 1 equation. So M R square is equal to, let us see, 4 cancel, pi get cancelled in pi square, pi times, and remaining things write down. Here what happened? N square, H square, this epsilon naught R goes to numerator. Epsilon naught R by what remains here? Pi Z square. Pi Z square. Now M transpose to other side. R square is equal to N square H square epsilon naught R upon pi Z E square into M. So one R get cancelled, R square R times. Finally what is the radius I got? Simply N square H square epsilon naught upon pi M Z square. So this is the radius formula for any nth orbit. Remember, the next one is how to calculate velocity. We have mvr is equal to how to calculate velocity. To calculate energy, I require radius and velocity both. So how to calculate velocity? How to calculate? We have the angular momentum formula mvr is equal to nh by 2 pi. So substitute the radius here. mv into what is the radius? N square H square epsilon naught upon pi m Z E square. That is R into nh upon 2 pi. Here what happened? N get cancelled in N square N times. H get cancelled in H square H times. And any others? Pi cancel. And here M cancel. So I required V. So V is equal to here what remains in numerator? NH epsilon naught. In denominator Z square. Transpose to other side is reciprocal. Then what happened? NH epsilon naught by Z square transpose to other side as a Z E square upon NH epsilon naught. And what remains here? By 2. So finally what is the velocity? Z E square upon 2 times NH epsilon naught. So here NH epsilon naught numerator, Z E square in denominator, transpose to other side, reciprocal, Z E square by NH epsilon naught. Here already 1 by 2 is there, so 1 by 2. Then what is the velocity formula? Z E square upon 2NH epsilon naught. So this is the velocity equation. This is the velocity equation. And by using these two, we are going to calculate the energy of the electron in nth orbit. That is kinetic energy, potential energy, and total energy. So what we are going to get the radius. Radius already we have here. What is that? Radius value n square h square epsilon naught upon pi m z e square. What is the velocity value I got here? Z e square upon 2n h epsilon naught. 2n h epsilon naught. 2n h epsilon naught. That is the velocity. Now I am going to calculate energy. Let us see. First, kinetic energy. Kinetic energy of electron in nth orbit. Nth orbit. How to calculate kinetic energy? Kinetic energy is equal to half m v square. Half into m into what is v? Already we have the relation z e square upon 2nh epsilon naught. So we need to remember this formula. Students, note down somewhere in one page, and this is also we need to remember directly to solve the problem. So these two formulas just note down at one place and remember. Radius of the electron, radius of the orbit, that is nth orbit. This is the velocity of the electron in nth orbit. Radius of the nth orbit, velocity of the electron in nth orbit. These two formulas are required. To solve the problem, derivation is not important. These two formulas are important to solve the problem in less than 1 minute time. Kinetic energy in NEET exam or IIT, of course. Kinetic energy is equal to half m v square. Half m, what is v square? Z e square by 2nh epsilon naught. That is the v. Already we have z e square by 2nh epsilon naught. There is a square. That's why I am going to do the square. Then what is the kinetic energy formula I got? Half m z square e power square whole square means e power 4. And this is the 2 square. 2 square is 4. This is the 2. And n square h square epsilon naught square. Here anything cancel means just cancel out. Otherwise leave it. If I am going to consider kinetic energy is equal to m z square e power 4 upon 2 times 4. This is the 1 by 2, no? 1 by 2 means like this. 1 by 2. So 1 by 2 means like this. So 2 times 4, 8 n square h square epsilon naught square. So this is what kinetic energy of an electron in nth orbit, direct formula. Suppose you require potential energy. Potential energy. We know that potential energy formula 1 by 4 pi epsilon naught product of charges by distance. So this is what the nucleus electron revolving in orbit. I am going to consider the radius is r. Radius is r. So how to calculate potential energy? 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught product of charges E into one more charge Ze. But here potential energy is a scalar quantity. That's why along with the negative symbol we need to substitute charges. Electron is a negative charge and proton is that means charge of the nucleus. Charge of the nucleus is positive. Why? Because proton has positive charge. That's why charge of the nucleus is positive. Electron charge is negative. Potential energy is a scalar quantity. We need to substitute along with the negative symbol by distance r. Then potential energy is equal to 1 by 4 pi epsilon naught z into, so that minus write down here, z times E into E square upon r. So potential energy is equal to minus 1 by 4 pi epsilon naught z E square by, already we have the r. What is r? N square h square epsilon naught by pi m z e square. That is goes to numerator. Pi m z e square. Here pi cancel and any others just multiply to minus z into z m. This is only 1m in numerator. Z into z square, e square into e square, e power 4 upon 4 epsilon naught into epsilon naught square, epsilon naught square, n square h square, n square h square. So that is the formula. minus mz square e power 4 upon 4 epsilon naught square n square h square. This is the potential energy formula. Student, here I am going to get two energies. One is kinetic energy and potential energy. Note down. What is the kinetic energy I got? Kinetic energy is equal to mz square e power 4 upon 8 n square h square epsilon naught square. That is the kinetic energy formula in nth orbit. Potential energy in nth orbit I got minus m z square e power 4 upon 4 epsilon naught square n square h square. This is the potential energy. Now what is the total energy? Now I am going to calculate the total energy now. Total energy means potential energy plus kinetic energy. What is the potential energy? Minus m z square e power 4 upon 4 epsilon naught square n square h square plus kinetic energy m z square e power 4 upon 8 n square h square epsilon naught square. That is 8 epsilon naught square n square h square. Both are same. N square h square epsilon naught square n square h square, both are same. Now what is the common? M common, z square common, e power 4 common upon 4 common, epsilon naught square common, n square common, h square common. Then what remains in the first term? Minus 1. What remains in the second term? 1 by 2 remains. 1 by 2 remains. Why? Because m z square e power 4 and denominator 4 common, epsilon naught square common, n square common, h square common. So for I'm going to write 8 as a 4 into 2, and I took 4 as a common, and in denominator 2 remains as it is. Now what is the total energy now? Total energy is equal to, let us see, minus 1 plus half, that is minus half, minus 1 plus half, that is minus half, that is minus half into m z square e power 4 by denominator as it is, 4 into epsilon naught square into n square into h square. So 2 4 is 8. That's why total energy we are going to get minus m 1 into m z square e power 4 upon 2 times 4 8 epsilon naught square n square h square. So this is the total energy formula. Student, totally 5 formulas are given here. Radius formula, if you want, write down this is as a Rn. Why? Because nth radius. If you require first radius means n value 1. If you require second orbit radius means n value 2. If you require third orbit radius means n value 3. So R1 year 1, R2 year 2, R3 year 3. So orbit number changes means n value will change. Nth orbit radius formula, this one. This is what velocity of the electron in any nth orbit. If you want, write down your suffix n. What is meaning of that? Velocity of the electron in any nth orbit. First orbit means n value 1. First orbit means v1, then n value 1. Second orbit means v2, then n value 2. Third orbit means velocity of the electron in third orbit means v3 and n value 3. Velocity of the electron in fourth orbit means v4, n value 4, like that. So kinetic energy formula in any nth orbit, potential energy of the formula in any nth orbit, total energy formula in nth orbit. So this is the 5 formulas we need to remember. 1 2 3 4 5. This is the 5. So radius, velocity, kinetic energy, potential energy, total energy. Just note down and remember those formulas. Derivations are not required, student. To save the time, just remember the formula. And there is a relation between kinetic energy, among kinetic energy, potential energy, and total energy. Here kinetic energy is equal to magnitude of the total energy. These two are equal. Kinetic energy and magnitude of the total energy, both are equal. Why I am going to put a modulus means kinetic energy is always positive. Total energy is negative. But their magnitudes are same. That's why I am going to write kinetic energy is equal to total energy. And potential energy, magnitude of the potential energy by 2 is equal to kinetic energy. That's why magnitude of the total energy equivalent to kinetic energy, magnitude of the potential energy by 2 is equal to kinetic energy. and the total magnitude of the total energy and magnitude of the potential energy by 2. These two are equal. Total energy is equal to, we are going to get find potential energy plus kinetic energy only. So these are the relation among kinetic energy, total energy and potential energy. So potential energy, total energy always negative, kinetic energy always positive. These are the points we need to remember about the energy of an electron in nth orbit, and the important formulas you need to write in your notebook. Radius of the nth orbit, velocity of the electron in nth orbit, kinetic energy, potential energy, total energy of the electron. That's all. And these two relations. So 1, 2, 3, 4, 5, 6, 7. These 2, 6, 7 points write down and practice. To solve the problem, that is enough. Thank you, students.